Hey there, Alpha here, and today I'm going to talk about a recent visit to some facilities at CERN. Located in the beautiful city of Geneva, by the Swiss-French border, CERN employs over 12,000 researchers in an attempt to figure out what happened in the first trillionth of a second after the Big Bang. After World War II, CERN was formed in Geneva with the aim of continuing the growth of world-class science without letting political tensions between its 23 member states get in the way of that. And of course, CERN is known for its Large Hadron Collider, or LHC. Electrons from a hydrogen bottle are first removed by passing an electric discharge through the atoms, leaving just the protons behind. Roughly 300 trillion protons are used in the beam, and I was surprised to learn that lead tungstate is sometimes used instead of the protons, resulting in showers of new particles when protons or electrons interact with their heavy nuclei. The beam is then accelerated 4 times through vacuum tubes of increasing circumference, with the use of superconducting electromagnets, so that when the particles finally reach the compact muon solenoid, or CMS, they have a velocity extremely close to the speed of light. The CMS is used to validate theories and is kept underground due to the severe radiation risks. The workers actually have to use the lift back up in the case of an evacuation, as climbing up about 100 meters of stairs would take too long. This machine checks the radiation dose, and if it is too high, showers must be taken to be sterilized. There is even an automated safety program for the detector, which connects internationally so that the facility can be controlled from miles away. The CMS is about 15 meters high and 20 meters long, with a mass of 14,000 tons. This huge mass means that compressed air must be used to move it, essentially turning the CMS into a giant hovercraft. Inside it, there is a tracker which tracks the trajectories of the collisions, filtering the noise of other particles by backtracking the trajectory, as the collision does not occur in a vacuum. Up to 64 petabytes of data were analyzed from 2009 to 2013, which is amazing considering that the data from only 1 out of every 6 million collisions is kept. Readings take 2 nanoseconds, and collisions occur every 25 nanoseconds. As the data is kept strictly confidential, the metadata is used for comparisons with Atlas. I found out that the researchers work for universities, and CERN is just a facility, so the international LHC computing grid is used to analyze data. Using the trajectories of particles, alongside magnets to check for particles versus antiparticles, the charges and velocities of the particles can be found. Charge, velocity, and the magnitude of the magnetic field are all proportional to the force. These factors, coupled with energy, allow for the deduction of particles. Many unique detectors make up the CMS, as it was put together in parts. This allows for the different detectors to spot a diversity of particles. Unfortunately, neutrinos are famously hard to detect, and there may be missing energy due to the production of neutrinos or other undetected particles. Both the strong and electromagnetic forces can be detected, but not the weak force. I was also told that inside the chamber, liquid helium is used, as it is the most suitable substance for the optimum temperature of 1.9 Kelvin. This does pose a risk, however, especially due to the rapid expansion of the gas, so special equipment must be worn when in the chamber. Some particles are able to escape the chamber, particularly muons, which have a high penetrating power, so much so that hundreds of meters of artificially grown crystals cannot stop the muons. These crystals are used, however, to stop electrons instead. In talking to my tour guide, I discovered that working in this specific area of physics can be difficult due to the slow rate of progress. It can often take decades for a theory to be validated, for example, with the Higgs boson, but I believe that this is something that can easily apply to many different fields of science in general. Progress takes time. Just take Geneva for example. So much progress has come from this small city. The Geneva Conventions for Human Rights, the formation of the International Committee of the Red Cross, the formation of the League of Nations, building the European HQ of the UN, and the creation of the largest international science experiment over the globe. This just goes to show that when countries work together in an international effort, great things can be done, amazing organizations can be created, and progress can be made. Progress will be made. Thanks for watching. See you in the next one.